This is a problem worked through for problem 158 in lesson 4.5, complex collision calculations. Now, what makes these problems more challenging than the previous section is that while we are still dealing with elastic and inelastic collisions, that is the momentum part of these problems, we do need to apply information that we've learned in previous lessons about horizontal motion, vertical motion, and acceleration. So these are not as straightforward. So let's start by reading the problem. Block A weighs 10 kilograms. It is initially at rest. It's going to slide down a 5-meter ramp with a constant acceleration of 3 meters per second squared. It will then, after sliding off the ramp, collide and stick to block B, which is 5 kilograms. So what is the final velocity of the two blocks? All right, so let's start with the momentum portion of this. And conceptually, let's just understand what's going on. Block A is going to collide and stick to block B. And we are looking for the final velocity of the two blocks. So that means that we have we have an inelastic collision. M1 V1 plus M2 V2 equals MT VT. Now, let's figure out what information we know. So we have block A and we have block B. So the mass of block A is 10 kilograms. The mass of block B is 5 kilograms. We know that block A is initially at rest. It slides down a 5-meter ramp with a constant acceleration of 3 meters per second. Well, if we know we need a V1, right, our initial velocity, and we need an initial velocity over here for block 2. Now, we know that block B is going to have a 0 meter per second velocity because A is sliding into block B. We know that the total mass is going to be 15 kilograms, and we know that the total velocity is actually what the question wants us to solve for. The problem is this initial velocity. Now, this initial velocity is the problem because even though it says block A is initially at rest, this can't be 0 because if this is 0, then then it can't slide into block B and they stick together. So that's where this other information comes in. We have a ramp that is 5 meters long. We have a constant acceleration of 3 meters per second squared, and that is where block A initially at rest comes into play because we need to find the final velocity of block A. And I'll put 2 question marks for that. So remember our acceleration questions, our acceleration formulas? Final velocity squared equals the initial velocity squared plus 2ax. Initial velocity, acceleration, distance, final velocity. So when we plug our values in, 0 squared plus 2 times 3 times 5. Well, 0 squared is 0. 2 times 3 is 6. 6 times 5 is 30. And that equals the final velocity squared. So the square root of both sides, the final velocity of block A, right, when it's sliding down the ramp, is going to be the square root of 30, which is 5.48 meters per second. That is the value that goes into this box, 5.48 meters per second. Now we can go ahead and plug our numbers into our momentum equation. So in this case, 10 meters per second, 10 kilograms times the velocity of 5.48 meters per second plus 5 times 0 equals 15 times final velocity. So 10 times 5.48 is 54.8 plus 0 equals 15 VT. Divide by 15. And 54.8 divided by 15 is 3.65 meters per second. So the key to this is being able to understand what's going on in the problem. This part right here is the part that is going to throw you off in problems like this. But remember, if the block is at rest, it can't slide down and intersect and collide with block B. So we have to think about what's going on in the problem. All right,